right? This is the fourth video for Module 12, Electromagnetic Force. We've talked quite a bit about electricity and how electricity works in a current in a circuit. We're going to talk about some very specific circuits today. So this is an example of an electrical circuit. What you saw in the video yesterday, you've got your battery here. This is your positive and your negative. This would be a circuit. I've added a couple more pieces to it besides the battery. This right here is called the resistance. So this could represent any type of resistance, like a buzzer or an alarm or a light bulb, a motor or a fan, anything that causes resistance to flow through there. And then this right here where this gap is, this is called a switch. So when you draw an electrical circuit and I ask you to draw something with resistance and with a switch and with a battery, this is what I'm looking for. Now, if you'll recall from yesterday, we have conventional and we have actual circuits or current flow. We normally, for real, you go from negative to positive, so you'll go to the short end of the battery and circle around to the positive, the long end of the battery. And the conventional current, you would go from the positive to the negative, which would be the long side to the short side. All right, so remember, this is your battery. It's positive and negative. We have a switch. We have resistance. This would be your actual current flow. And then red one on the inside is going to be your conventional current flow. You'll have to draw a picture like this on the test, so go ahead and make a copy of it in your notes. Make sure you understand all the pieces of it because it will be on the test. So in an electrical circuit, you're going to have resistance. Remember, I talked about how if you connect your hands, your fingers, on either end of a positive AA battery, and you have one finger on the positive and one finger on the negative, your body is offering the resistance in there. So resistance is anything that slows down the current in a circuit. So light bulbs are a type of resistance, like I said, or fans, or alarms, or motors, or just your human body. The circuit itself, the wiring that's made out of, can offer some resistance as well. So all metals resist the flow of current differently. So they're all going to be different. They're not all made the same. How much they resist will determine whether they can be used or how they will be used. Most of the time, and if you take just any wire that is being used in an electrical device and you strip back the wire, the covering that protects us, you're going to find copper wire. Copper is often used in electrical circuits because it is low resistance and it doesn't get very hot. And then it's also light. Now, when a metal does resist current, they will produce heat. Think of like a stove. If it gets hot, I mean, like when the current is flowing through the oven top, your stove top, not all parts of it are going to get the same amount of hot. So where the metal is, it gets really hot, we are going to be then using that heat to cook. So metal resisting current is either going to produce heat or it's going to produce light, like a light bulb. The way a light bulb works is there's a wire inside the light bulb that when the current hits that, it lights it up. So some things are going to produce heat and light. So if you've ever looked at the stove top whenever it's really, really hot and it turns red and it gets hot, all right? So it produces heat and light. That's how you know that it is resisting current. Now, if you have a circuit that is open, is not connected from the negative to the positive end of your battery, then the current can't flow because the connection's incomplete. There is a gap. It is open. Now, sometimes you want a circuit to have a gap sometimes, like you don't want your lights on all the time. So that's what a switch is used for. It can open and close the circuit in order to make the device be operated or to shut it off. Now, this is a series circuit. It is called a series circuit because all of the resistance is in one single line. There's only one way for the electrons to, or not the electrons, the current to flow, and it can only flow this way, all right? So it's in series. The problem with series is if this bulb gets burned out because the little wire filament on the inside gets broken, then all of them are going to go out even if there's nothing wrong with them. A lot of Christmas lights are done in series circuit, especially if they're really cheap ones, where if you lose a bulb, the whole string is gone. They're all out. A lot of things aren't used in series circuit, not really very often. So if we were to draw this in a normal circuit, so we would have our positive and our negative side of our battery. So then I'm going to have my line. So I have a resistance here and a resistance here and a resistance here, and come up to my battery right there, so that I have my 1, 2, and 3 light bulbs, right? So series circuit, there is a single pathway for the current to flow. The problem with series often is if one goes out, they all go out. The other type of circuit is called a parallel circuit. Now what works for this one is that no matter what happens to one of the bulbs, the other bulb will stay lit. So let's say that this one breaks. Well, these wires aren't actually connected and have nothing to do with that light bulb. They are connected to, so this battery, even though it looks like it's connected to that light bulb, it's actually connected to, the light bulb is connected separately to that battery. So as long as the battery is good and this light bulb is good, if that one goes out, this one will stay lit up. So a lot of your more expensive Christmas lights are going to be in parallel. Now you can tell if something is in parallel is because if you lose one light, they both stay lit. So a lot of modern automobiles, usually if one headlight goes out, the other will stay on. And so then you just only have a single headlight. People call it different things. But when I was growing up, some of the cars, their headlights were in series circuit, so that if one headlight went out, they both went out, and now you didn't have any working headlights. So parallel, if one goes out, the others stay on altogether. All right, so the way you would draw this is you have your positive and your negative circuit. Okay, so if it's going down here, we might have our resistance here. Remember, our resistance is a squiggly line, and then we can draw another squiggly line like that, and that would be a parallel circuit with 2 resistors. Click on the link, do your homework. I'll see you in class.